Okay, so for this video presentation, we'll be discussing the introduction to statistics. So um, the coverage of this video includes the statistical process, the definition of statistics, and then some definition of terms. Okay, so let's start with defining what is statistics first. Now, um, when we speak of statistics, okay, when we speak of statistics, normally people always freak out when they hear the word statistics. Why? Because the main reason why people don't feel a strong connection with the word statistics is because of they see intimidating formulas with like this one with fancy Greek letters, and some people might say na let's call it a day, okay, because this formula is somewhat complicated, okay, and then that's the image of statistics, okay. But the truth is that statistics is not a challenging math subject, okay. So the formulas that we'll be having in statistics are simple. It's actually a step-based formulas or steps-based formulas or process-based formulas. And throughout the discussions for statistics and throughout the SEM, we'll be providing lecture videos, okay, in which we'll be simplifying the steps for you to appreciate statistics. So that's actually the goal of this particular part of the course, for you to be able to understand statistics, for you to be able to appreciate the formulas which are found in statistics, and for you to apply it on your research paper. Okay, so again, statistics is not a difficult math subject. It's not a challenging math subject. But when we speak of statistics, it's really a study of making decision or drawing a conclusion. Okay, so with that in hand, with that in mind, let's try to have our working definition for statistics. Now, when we speak of statistics, it's yes a branch of science, but it covers a process. So what is that process? So this one, you have the collection of data, you have the organization of data, the analysis of data, and the interpretation of data. So what data are we referring to? You have quantitative data, okay? And the goal of the statistical process is for us to arrive at a decision, okay? For us to be uh, aided in terms of our decision making process. Now, when we speak of statistics, okay, it's actually found everywhere. So from individual researches to business operations and even government operations. So the word statistics is actually in its both singular and plural form. So pag sinabing plural form na statistics, it refers to a set of figures or data. So for example, the height of students, okay, the BMI of students, the scores of students in, let's say, the midterm exam. Those or uh, that particular aspect of statistics is in its plural form. Now, when you speak of the singular form of the word statistics, okay, it actually covers the whole body of tools that we are using for us to collect data, for us to organize, interpret, analyze the data, okay, and to draw conclusions from those data. Okay, so to simply put, the plural form of statistics cover the numbers, the figures, okay? While the singular form refers to the subject matter, okay? So there. Now, when we speak of statistics, it involves the following processes. So based on our definition, these are actually the processes involved. So first, you have the collection of data. So in terms of data collection, this is actually the process of gathering relevant information. Okay, it covers the process of gathering relevant information. So uh, when we speak of data collection, it can be in the form of, let's say, direct method or indirect method. So for a direct method, you'll be doing an interview, okay, in which you will be gathering information or first-hand information directly from the source of the information. And you can also have, let's say, indirect method. So for indirect method, that's the most popular way for you to collect data through indirect method is actually the or if you will administer questionnaires. Okay, or you can also do observation, okay, or a registration method or even experiment. So those items will be discussed uh, in our succeeding slides, okay, because we'll be having a separate discussion of the collection of data portion. And then next is the tabulation of data. So in terms of tabulation of data, it covers uh, the uh, presentation of data and how are you going to organize data. And normally in statistics, we tend to present data in the following form. So you have your textual presentation, you have your tables, or we also have the frequency distribution table. We have charts and even graphs. Okay, so next process is the analysis of data. So first step, you will gather relevant data. Second step, technically you will summarize those data. Okay, you will uh, put it in a form in which it's easily understood, plus as a reader you can comprehend those data. And the third step involves the analysis of the data. So in terms of the analysis of the data, normally it's where your measures of central tendency, measures of variability, measures of dispersion would come in. Okay, or if you're familiar with the terms mean, median, mode, okay, it's actually some tools for you to analyze data. Okay, so after the analysis of data, you will now interpret, or you will let's say derive a conclusion. Okay, or you will infer. Okay, now um, for the presentation or for the flow of our discussions for statistics, we will actually follow this process or processes rather. Okay, so on this video presentation, I will be discussing uh, the ways on how we're going to collect data, and then some methods on how are you going to present the data that you have collected, and then we will be having a separate discussion on the tabular form or the tabulation of data, in which we'll be constructing the frequency distribution table. And then after that, um, for us to help you in terms of the chapter 3 of your research, we'll be having a separate discussion for the analysis of data, in which we will cover the measures of central tendency for both group and ungrouped data. And then we will be also covering the testing of hypotheses, plus the measures of um, dispersion. Okay, so we will be covering all of those. So that's the flow of our discussions for statistics. For the goal of helping you in terms of your research paper, or in terms of writing your research paper rather. So um, from the statistical process, if we will relate that to your research paper, okay, statistical process is actually part of the whole research process. Okay, so in statistics, the research process that you are you are doing, we call it as your statistical inquiry. Okay, so in terms of your research process, your statistical inquiry, okay, the first step, which your advisors are always reiterating, okay, um, during the proposal of your research topic, okay, the first step is actually the identification and formulation of a problem, research problem. Okay, and then once you have identified the problem, you may state hypothesis if there's a need. Okay, or if there's no need for hypothesis, then as long as you have already chosen a problem, a research problem, then that's already good. Okay, now in terms of choosing the problem, you need to choose something that interests you. Okay, and then in terms of choosing a problem based on the discussions provided to you on the introduction to research, business research, the topic should also be feasible. You need to consider the technical know-how, okay, your budget, and even your time frame. And then, in terms of choosing a problem, it should be a research-worthy na problem. Okay, so it should be based on needs and wants, for example. Okay, and after choosing the problem, you will now formulate your research design. So in terms of formulating your research design, so it can be a quantitative or qualitative research depending on what discipline of research you are doing. So after the formulation of research design, your statistical process would come in na. Okay, that's why um, in this particular course, diba, you have two descriptive titles. You have business research and statistics. Okay, so that's the main reason why statistics is incorporated in your BR class. It's not for us to give you a difficult time in terms of your research, but it's actually a a way for us to help you in terms of your research paper. Okay, so there. Now, let's discuss the divisions of statistics. We actually have two. So the first one is your descriptive stat or statistics. So for descriptive statistics, uh, it's concerned with summarizing and describing important features of numerical data without attempting to infer. So when we speak of inference here, it refers to um, deriving or arriving at a conclusion. So meaning when we speak of descriptive statistics, we will just uh, try to describe and understand the features of a specific data set by giving short summaries about the sample and measures of the data, okay, in which you will not conclude. You will just simplify the data, okay. An example will be, or an example of a descriptive statistics is, let's say your general weighted average. Okay, so let's say upon getting your grade slip last term, you have, let's say, 8 subjects or 8 courses in which you have different grades, final grades. Okay, so that's your data set. Now, when we speak of descriptive statistics, for you to summarize, let's say your grade is by computing for your general weighted average. So, for example, if your average is 90, then it uh, describes that you have done well, okay, in your previous sem. Okay, but uh, upon describing your general weighted average, it does not necessarily uh, conclude that, let's say, you are a very smart person or you're not that smart. Okay, because again, you are just describing the number. Okay, you are just describing the event. Okay, so there. What I'm telling here is if you have grade or if you have general weighted average of 75, it does not mean you are not smart. Okay, maybe you are smart with uh, the other aspects of life. Okay, so let's say you're not good in math, but you're good in arts, okay? Or you're not good in math, but you're good in, let's say, science, okay? So that's descriptive statistics. And then we also have inferential statistics. So for inferential statistics, the goal here is not for you to describe, but for you to arrive at a conclusion, okay? In which normally for descriptive statistics, the tools that we are using are your measures of central tendency, your averages, your mean median mode. And then for inferential statistics, it's where you will be using your t-test, j-test, or the different tests of hypothesis. Okay, so again, the main difference is that descriptive statistics describes the data, while inferential statistics allows you to make predictions or inferences, okay, or conclusions. Now, um, here are the basic terminologies that you'll be encountering in terms of statistics. So we have population and sample. So what's the difference between the two? Population is the complete set of individuals. It's the totality, okay, of your data set. While sample represents, or samples are considered to be the representative cross section of the elements drawn from population. Or to simply put, as an analogy, population is the whole pie. Okay? Sample is just a piece of the pie that will represent the whole pie. Okay? So another analogy, let's say um, the student body of CBA. Okay? So that's the whole population. When you speak of a sample, let's say your black section. Okay, it represents, let's say, the whole population, for example, in which you're not the total population. Okay, so there. Now let's move on to parameter and statistics. So as I've stated a while back, when we speak of statistics in its plural form, it represents numbers. Okay, so in here, in relation to your population and sample, the number that represents population is considered to be parameter, and the number that represents the sample is considered to be statistics. Okay, so uh, as an analogy or an example, let's say there are 300 CBA students, okay, and then uh, you represent the whole population of CBA students. Let's say your black represents the whole population of C-based students, in which, let's say, the number of students in your block is 50. Okay, so that 50, which represents the whole, okay, is considered to be the sample, in which it's referred to as your statistics. However, the whole 300 students, okay, that number 300 is considered to be parameter. Okay, so there. And another one, we also have what we call your variables. So for variables, these are the characteristics or condition that can change or take on different values. So how can we gather characteristics? So we can do it by, let's say, measuring, or by counting, or observing, or even asking or computing. Okay, so for example, in terms of age as a variable, so how are you going to gather that information? Diba? You can measure it, okay, or you can, let's say, count it, or you can ask, okay, or in terms of computing, let's say by merely having the data of the birth date of the person, right? Then you can compute for the person's age, and then you can ask the person, okay, so about his or her age. And for the variables, okay, so again, ways on how you can gather these variables or characteristics are as follows. So you have your measuring, counting, observing, you can ask, or you can compute. Now, for the classifications of variables, so as to functional relationship, we have two classifications. You have your independent and dependent. So independent is also known as your predictor variable, in which these are the values that can be changed in a research. Okay, and then your dependent variable are considered as your criterion variable, in which the values that you'll be deriving here are actually results coming from your independent variable. So for you to better understand, let's say um, allowance and motivation. Okay, for you to relate it with your lives being a student. Diba? If you'll be having higher allowance, then you'll be motivated, or you will be more motivated. Okay, in which if you will look at the relationship between those two variables, your independent variable is actually your allowance. Okay, in which it will affect the dependent variable, which is your motivation. Okay, so I'm not telling na you go to your parents, then you will tell na uh, if you would like me to be more motivated in my studies, give me more allowance. Okay, I'm not telling you that, but that's just my analogy. That's just a hypothetical example. Okay, or another example would be, let's say, retention rate of employees and uh, motivation. Okay, so if they are highly motivated, then we will stay with the company. Okay, so motivation is your independent, dependent is retention. Okay, so there. Another example, let's say your scores in the exam, which is a dependent variable. Independent variable, your predictor variable is your, let's say, attitude in class, or your participation in class, or the amount of time that you will be allocating for you to review the lessons. That's an independent variable. Okay, so that's the relationship between the two. Next, as to continuity of variable, so, or of values, we actually have two classifications. You have continuous variable, and then you also have your discrete or discontinuous variable. So what's the difference between the two? The decimals. So if the variable can take form, or can take the form of decimals, so this should be off, then it's considered to be a continuous variable. But if it cannot take the form of decimals, then it's discrete or discontinuous. So what are examples of continuous variables? So you have, let's say, the prices of commodities. Okay, diba? There's the centavo part. Okay, so let's say 250, 150. Okay, or let's say height. Okay, so 1.73 meters. Okay, there's the decimal form. It's not pure whole numbers. Okay, and for discrete or discontinuous variables naman, example of which are, let's say, number of students in a class. There's no such thing as zero point 0.5 na student. Okay, so you are always considered to be one student. Okay, so number of students will always be in the form of whole numbers. There's no decimals, or even number of houses. Okay, you cannot say na your house is zero point 0.5 because it doesn't have, let's say, a door, a window, or whatsoever. Okay, or even the size of the family. That's also a discrete number. And another one, you also have your qualitative data. So for qualitative data, these are uh, categorical data, in which it takes the form of attributes or categories, or these are merely names, okay, or labels assigned to a respective category. So example of which is, let's say, if you will collect the data in terms of the color of the eyes. Okay, so it can be, let's say, brown, blue, or whatsoever. Or let's say the type of the lawyer. Okay, that's another data na you can have, pero it's in the form of qualitative data. So let's say a prosecutor, a private practitioner, okay? Or your year level as students. You can be a first year student, second year, third year, and so on. Those are qualitative data. Or to simply put, when we speak of qualitative data, these are non-numerical information, okay, in which you cannot perform your mathematical functions. You cannot divide the data, you cannot subtract a number from the data, you cannot add or you cannot multiply. Okay, so next is your quantitative data. So this type of data naman is the or this classification of data naman is the type of data in which you can now perform your arithmetic. So you can add, you can subtract, you can divide, you can multiply. So examples of which are measurements like weights, height, ages, okay, and other quantities, measurable quantities. And another classification of data. So you have another form in which it can be raw data or array. So what's the difference between the two? Raw data is the data that you have gathered in its original form. And then if you will arrange that from lowest to highest or highest to lowest, then it's now considered as your array na type of data. Okay? So for example, if you will ask your classmates, like let's say you will ask their age. So let's say one person will tell na he or she is 18 years old, the other one is 20, and then the other one is, let's say, 19. Okay, so upon listing or enumerating that data, so we have 18, 20, and 19. Okay, that arrangement is in its raw form. But if you will arrange it from lowest to highest, so for example, 18, 19, 20, or 20, 19, 18, then that's already in its array form. Okay, so for the measurements of scales, so what does that mean? As I've stated a while back, diba, qualitative data is a type of data in which you cannot perform math or mathematical functions. However, in statistics, you can actually convert those qualitative data into a quantitative data for you to perform your mathematical equations. So how are we going to do that? Through what we call measurements. Okay, so measurement is the process of determining the value or label of a particular unit of analysis. Okay, so in which, let's say, in terms of determining the value, you can have your um, quantitative measures in which normally you have the Likert scale as an example. Okay, so if this is the answer of the person, you can equate that to a particular number. Okay, so for example, if the person will say yes, then it has a corresponding score of 1. And then if the person will say no, then it has a corresponding uh, score of 0. Okay, so in that manner, you are actually converting the data already in a quantitative form, okay, for you to process it in uh, the succeeding parts of your research paper. So if we will classify the data according to measurements, we have the following. So first, you have your nominal scale. When we speak of nominal scale, these are numerical values or symbols that uh, are used to classify the following. Okay, your object, person, or even characteristics of a group. Now, when we speak of a nominal data, these are actually merely names. Okay? Nominal scales only permit you to determine whether or not two individuals are the same. Okay? So, again, for a nominal data, these are data na you cannot arrange it in an ordering scheme. Or, to simply put, you cannot arrange it from highest to lowest or lowest to highest. So, examples of which uh, are as follows. So for example, the number of your house number in your barangay. That's actually a nominal scale na data. It does not represent the arrangement of your let's say, it does not represent the arrangement of houses in terms of its size. Okay? It's a nominal data in which it only represents the label of your house. Okay? Another one, or another classification, is your ordinal scale. So for ordinal scale, um, it's a measurement in which it will tell you now the direction or difference between two variables, in which for an ordinal data, okay, di ba, nominal data is just a label. You cannot rank it from highest to lowest or lowest to highest. But for ordinal data, it contains the same level, or it contains the properties of nominal data rather, and then on top of that, you can now arrange it from highest to lowest or lowest to highest. So example of which is, let's say, the educational attainment of a person. So you have, let's say, elementary graduate, high school graduate, okay, uh, a holder of a bachelor's degree, in which, diba, there's ranking. Okay, you know that after your elementary degree, you'll be having your high school and then your college. Okay, you have that particular order. But in terms of ordinal scale, the exact difference between those variables, between those ranks, are not actually properly defined. Okay, so for example, the um, socioeconomic class. Okay, so you have your um, let's say class A, you have class B, class C, class D. It's ordinal in the sense na, yes, you can rank it from A to C or C to A. However, you don't have a particular interval, okay, between, let's say, A and B and B and C. Okay? Or let's say yung uh, letters that represent the scores in an essay exam. Let's say A plus, A minus, A. Okay? Or ABC. Okay? So, um, yes, you can arrange it na A is the highest, C is the lowest, but you don't have an exact interval, okay, for you to measure, or for you to compute for the difference between A and B, or between B and C. Okay, so that's ordinal. And then the next level of measurement is your interval scale. So for interval scale, it contains the properties of ordinal, in which you can rank this data, okay, according to, let's say, lowest to highest or highest to lowest. And then you now know that, okay, there's um, equal intervals between the numbers, or between the scales. Okay, so example of which are as follows. So for example, the months, okay, in a year, di ba, normally there are 12 months in a year. Okay, so meaning you can actually count the number of months in which that's you have the same intervals, let's say, between to January 2017 and January 2018. You know na it's 12 months. Okay, and then January 2019, January 2020, okay, you know na it's still 12 months. Okay, you have exact intervals. And in terms of interval scale, the units of measurements are arbitrary, in which zero does not mean that the characteristic of that particular data is absent or inexistent. Okay, so an example of which is temperature. Okay, di ba? If let's say the temperature is zero, it does not necessarily mean that there's no existence of temperature. Okay, kaya it's arbitrary. Okay, so that's for interval scale. So again, so what's the difference among the three? Nominal numbers are merely labels, names. You cannot arrange it from highest to lowest. Okay, and then here comes ordinal. For ordinal, the numbers or the data can now be arranged from highest to lowest, but the intervals between the numbers are not known. And then you have interval scale, in which the data can be arranged from highest to lowest or lowest to highest, and then the intervals are of known sizes. But numbers or the unit of measurements are arbitrary, okay, in which 0 does not mean that the characteristic is absent or inexistent. And last, we have our ratio scale. Okay, so ratio scale. Um, Ratio scale is the strongest level of measurement, in which it tells us about the order. Okay, highest to lowest. It has exact value between units. Okay, you have your proper intervals, and then it has a true 0 point. So what does that mean? If the value is 0, it means that it's inexistent. The characteristic is inexistent. Okay, so example of which is height. Okay, if your height is 0, it means that you're inexistent. Okay, or let's say um, your money is a bank. If it's 0, it means that you don't have money, really. Okay, so there. So here's some examples. Flavors of ice cream, let's say double dutch, ube, cheese, or whatsoever. Okay, it's what type of data? It's actually a nominal data. Okay, so you cannot arrange na let's say double dutch is the highest. Okay, uh, cheese is the lowest. That's just nominal data. And then amount of money in savings account, this was actually my example a while back. This is a ratio scale. Why? Because if you have zero balance in your savings account, it means that there's absence of money. You don't have money. Okay. And then you also have classification of students by their reading ability. So you have above average, below average, and normal. So in some instances, if you have a defined intervals between, let's say, above average and below average, your normal and below average, then it can be an interval measure. So it's interval because if, let's say, you'll be having a 0 na value, it does not mean that or 0 has or 0 is arbitrary. Okay, in which it does not mean that it's the characteristics absent or inexistent. Okay, so for example, um, your reading ability, okay, if it's 0, it does not mean na or in terms of reading ability, there's no such thing as 0 value. Okay, to simplify. And then number 4, your letter grades on an English essay. So I've given this as an example also. This is actually an ordinal. Okay, you can rank it from lowest to highest or highest to lowest, but there's no specified intervals between the variables or the data. And religion, it's actually nominal. Okay, so there. Now let's move on to the collection of data. For collection of data, you can have the following sources of data. So you can have documentary sources or the data which is contained in a printed form. So when we speak of primary data, these are uh, original na gathered data, in which these are first-hand gathered data. Okay, and it comes from, let's say, the author. Okay, the source is the author. And you also have your secondary data. So data that were previously gathered from an original source, which are, let's say, computed and compiled. Okay, so meaning that's they are not the original authors of that particular data. And we also have your field sources. So sorry. Okay, so we are at collection of data. Okay, so there. Documentary sources, these are the data which are found on a printed form. So examples are, let's say, your journal articles, okay, uh, dissertations or previous researches na published. And then field sources, if let's say you don't have printed data, or if the data is not contained in a printed form, then you can gather data from the experts. Okay, so in which you will gather data from individuals who have sufficient knowledge and experience about what you are trying to research on. So for example, if you will study how hard it is to sell life insurance, for example, or memorial plan. Okay, now for you to gather the data, diba, it's not printed on books, it's not even found on newspapers, it's not contained in a printed form na data, but you can, let's say, go to the salespeople of those products and then you ask them how hard is it really to sell memorial plan or insurance products. Okay, that's actually field sources. And in terms of collecting data, you can also have your direct method or your interview method, in which you can follow the following steps. So first, you will do rapport building, okay, in which you being the interviewer should increase the receptiveness of the respondents by making the respondent believe that his or her opinions are very useful to the research. Okay, and of course, you need to remind the respondent that his or her answers will be treated with utmost confidentiality. Para they will also be confident in answering your questions. And then after that, you also need to introduce yourselves, and then you also need to introduce, or you also need to discuss why are you doing this particular study. Okay, and next is your probing. So for the probing, that's actually your Q&A portion na. So probing is actually a technique of encouraging the respondents to answer completely, freely, and relevantly. Okay, that's actually an art. And then um, you need to do the recording. So in terms of recording, um, you being the researcher can either write the response at the time of interview or after the interview. Okay, so normally uh, it's best pa rin to ask the respondent whether it's good for them na you will record their responses while they are speaking or after the interview na lang. Okay? And the closing, so for the closing, you need to thank the person for the time that he or she spent with you for you to complete your interview process. Okay? So next is your indirect method. For indirect method, uh, it's also known as your questionnaire method, and the success of this method actually depends on the proper drafting of questions. And um, this is the most common type of data gathering tool. Okay, so your questionnaire. So when we speak of questionnaire, these are series of questions in which the researcher have formulated for him or her to gather relevant data, okay, or relevant responses to, uh, let's say, to answer a particular research problem. And what are examples of questionnaires. It can be structured or unstructured. When you speak of structured questions or questionnaires, these are close-ended questionnaires. So, for example, uh, the true or false questions or yes or no questions. Okay, unstructured, these are open-ended, in which, as an analogy, it's like your essay questions. Okay, na the answers will be free-flowing. Okay, it's not close-ended. And here are types of structured questionnaires. So dichotomous, it means that the respondent will make a choice between two responses. So for example, the sex, male or female, okay? Or the questions yes or no, or true or false. And then you also have multiple questions, okay, in which the respondents are offered more than one choice. For example, your uh, evaluation for teachers, di ba? You will rate the teacher in terms of, let's say, his or her teaching strategy, and then you have choices na excellent, superior, very good, good, or needs improvement. Okay, so that's a multiple uh, choice type of question. And we also have your rank and order approach or questions, in which the respondents are asked to choose a response from the most to the least, for example, or least to most. And an example of which would be, let's say, if you will ask a person what is the most influential thing, okay, in terms of his or her study, or uh, let's say if you will ask a person what is the person's favorite Filipino dish, okay, in which you have given the choices, and then the person will just rank, let's say, 1 is the highest, 5 is the lowest, okay. So that's for your rank and order approach. And then for your rating question, so the respondents are asked to judge something along an ordered dimensions. So rating questions are typically bipolar in nature, and normally um, it answers yung mga questions regarding the level. So for example, level of influence, of incentives to motivation. You have your influential, very influential, extremely influential, or not influential at all. Okay, so in which the respondents will rate. Um, Another method for you to collect data is through registration method. So for this one, instead of conducting interview, or instead of you administering questionnaires, you can just um, go to a particular office who has data, okay, or who's keeping the data that you need. So for example, the registered professionals, you can uh, go to PRC, okay, or mortality rate, population growth rate, you can just go to PSA, okay. And for a registration method, it's actually governed by law, so that's the advantage of registration method, in which somewhat it's the most reliable source of data, because again it is enforced by law, okay. And disadvantage, so data is limited to what are listed on the document lang. And another way for you to gather data is through experiment method. So this is a type of collection of data where the researcher will influence the responses, okay, in which it's actually the application of your dependent and independent relationship na, okay, or variables rather. So for example, if you'd like to test the effectiveness of, let's say, a medicine, okay, then you will not administer questionnaires, you will not, or uh, conducting an interview is inappropriate for you to gather the data, but you can do experimentation for you to gather the relevant data, okay. And Last is your observation method. So this is used to collect data pertaining to attitude behavior. Okay, so um, an example of which is, let's say, if you will observe, or if you will research on the pattern of traffic lights. Okay, so you cannot interview naman the traffic light, and then you will ask, okay, what is your pattern, di ba? So that's illogical, that's inappropriate. That's why you can utilize observation as a method to uh, get the pattern of traffic lights, or the condition of the roads, or even the quality of houses. Okay, so there. And uh, on our statistical process, after the collection of data comes your presentation of data. So for the presentation of data, we'll just go through, or go over with the different methods on how you can present your data. And then for the frequency distribution table, we'll be having another recorded discussion for that. Okay? So for the presentation of data, it can be in a textual form, tabular form, or graphical form. So the goal for this part of the statistical process is, again, for you to summarize the data so that it can be, or it will be comprehensive for you being the researcher, and even to the readers of your research. So here's an example. Let's say these are the scores of Mr. Marcelo's students in their prelim exam. Okay, so for Mr. Marcelo to present the data, so this is in its raw form. For him to present it in uh, a better format, he needs to convert the raw data into an array form muna. So how are we going to convert it again into an array form? By simply arranging the data from lowest to highest, for example, or highest to lowest. Okay, and then after that, after arranging your data from lowest to highest, or highest to lowest, then you can now present your data in textual form, tabular form, or even your graphical form. So for example, let's have the textual presentation. For the textual presentation, you will just tell the story of your data in a textual manner. So for example, in here, we know that Mr. Marcelo has 40 students. So how have we identified that Mr. Marcelo has 40 students? You count, di ba? You have 40 scores here, okay, which represents 40 students. So in here, it states that in the statistics class of Mr. Marcelo, okay, which has 40 students, 3 obtained a perfect score. So here, okay, so let's say it's over 50. And then, um, so that's 3 out of 3 who got perfect score of 50. And then there are 16 students who got a score of 40 and above. So if you will count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so you are presenting the data in a textual form, but it's still based on the given set of data. Okay, so that's the textual presentation. And then for tabular presentation, you can put it this way. So you group the students based on their scores, and then you uh, identify the frequency, or how many students belong to that particular group. So in here, for the students who got 50, we only have 3. So 1, 2, 3. In which, for the frequency, it's 3. Okay, and then relative frequency, this is actually their proportion to the whole population, to the total. Okay, so there. And the data can also be presented in a graphical presentation. So examples of which are line graph, your circle graph, map, or even your pictographs or pictogram. So here's an example of line graph. So based from our data, there are 3 individuals who got 50 perfect score, and then there are 20 students who got a score within the range of 38 to 49, and uh, we have less than 15 for 20 to 37, and less than 5 for 19 and below. Or you can do bar graph. Okay, so this is the same data. Okay, so 3, okay, but you have just presented it in a bar graph, okay, instead of a line graph. Or you can also have your pie or your circle graph. So in here, um, the students who got 50, okay, so we have 3 out of 50, so that's 7.5%. So let's uh, assume that this is the the students who got perfect score, and then your 19 and below, which is also 7.5, because it's 3 individuals, so that's this portion of the pie. Okay, and then the students who got 38 to 49, so that's 50%, 20 out of 40, and then 20 to 37 na score, you have 35%, for a total of 100%. And you can also have pictograph or pictogram, in which you will be using small identical pictures or figures, okay, in terms of making comparisons. So example of which is this one. So let's say um, one picture of a person represents one student. So in here, it states that there are 3 students, 1, 2, 3, who got a perfect score. And then there are 20 students who got 38 to 49. Okay, so if you will go back to the classifications of data, this data is considered to be discrete, correct? So meaning you will not see a data na decimal, okay, because we are referring to people. Okay, and for the frequency distribution table, as I have stated a while back, there will be a separate discussion for this one. So this will end my presentation for the introduction, and hopefully you have learned something from this discussion.